So today we are going to be working on rotations, and we are going to talk about how not all rotations are isometry. So before we begin, I'm going to start out by telling us, or by talking about what an isometry is. And an isometry is a transformation that preserves distance. So if you remember last time we talked about Etch-a-Sketch translations, and we figured out why all translations are isometric. So the first thing you might remember is that, and today we are going to be doing it on rotation. So before, I even give you a process, I'll tell you the definition of rotation. So rotation is given a center point, a direction clockwise or counterclockwise, and a percentage. You first draw a circle with a center point that goes through the point to be rotated. Then you find the point on the circle that is the given percentage of the circumference from the original point in the specified direction. This is the new point. This new point is the image. So one thing you may remember from the translations video is if an isometry preserves distance, we know that the initial distance and the translated distance need to be the same, and we showed you that whole process of subtracting the points and everything. So now we are going to work on that with rotation. So it's similar in the sense, like the process of the adding and subtracting is similar, except we move in a different way. We don't move by like direction up and right. We move by a percentage, and we say counterclockwise or clockwise. But to start out, we do need to start out with initial points. So here, I'm going to use this picture. Our initial points, we have our origin 0, 0, our initial points. Our initial points are, I drew this poorly, but I'll redraw it over here. So sorry. So our initial points are, let me just draw this quickly, 0, 0. We are going to, okay. So we are going to, okay, so now our initial points we'll draw. I just didn't draw it correctly here, but it's supposed to be the same thing. Our initial points are 1, 0, and 0, 1. So I'm going to move us over to this picture, and I'm going to have you just pretend that that's 1, 0, and 0, 1, please. So we know those are our initial points. Now we need to find our initial distance, and we remember that we did that by taking what we would say is point, sorry, I'm so sorry, taking point C, which would be this 0, minus point A, which is the 1, right? Because here, I'll draw it up here. This would be A, B, C, D. So we take C minus the 1. Okay. And then we take D minus the B, right? So what we do is we always put these in absolute value. So even though it's 0 minus 1, which I did over here, it's just going to be 1, right? Not negative 1. And we did 1 minus 0, which is 1. So we have here 1 plus 1 equals 2. Okay, so that is our initial distance. So now on our figure, that is the distance points are the same, we are going to add a rotated point. So we remember that our origin is 0, 0. However, I am going to have us rotate 1/8 of a circle counterclockwise. So if I'm starting here at our first initial point A and B, we have to go up 1/8. So essentially, that is actually like moving up 1/2. So we start from the origin, we go over 1/2 and up 1/2. And so that point is right here. Okay, so our first point would be 1/2, 1/2, which we write here, 1/2, 1/2. So now for starting from our second point, we are going to do the same thing. We're going to go, for moving counterclockwise 1/8, we are going to go down 1/2 and over 1/2, right? So that's our other point would be negative 1/2, 1/2. Well, now all we need to do is calculate. So our new distance, we are going to take C minus 1/2. Sorry, C minus 1/2, okay? So that's basically giving us 1/2, so sorry. And then that's the same as the other one, is this is giving us 1/2 as well, 1/2 plus the 1/2. Or where this would give us, 1/2, and then plus, I'm so sorry, that would give us 0, plus this 1/2 plus 1/2 is going to give us 1. So our new distance is 1, which is not equal to 2. So essentially, we were just able to prove, based on this one instance, because we found one example that did not work, that not all rotations are isometric. Okay, so now we know that because these did not, the distances were not equal, this was not an isometry. Thank you for listening.